Hey everyone, welcome back to the channel. So in today's video, we will be doing understanding basic logarithms. So in the previous problem solving video, I got certain queries that some of the students didn't understand what is the basic idea of logarithms. So in this, I'll be explaining what are logarithms and what are the properties of logarithms. Okay, so let's start with today's video. So first of all, we all know, let's take a number a raised to the power x is equals to b, where a is the base, x is the exponent, and b is the answer for this. So it means that a multiplied x times is b. This is just an exponential expression. Now, if we know a and b, suppose a is 2 and b is 4, we know that the answer of x will be 2 because we already know this. But if we have 2 raised to the power x is 5, then we may face a problem in this because we don't know that what we need to raise to the power to 2 so that we get a 5. But in this we know that x will be 2, and that's where the use of logarithms come up. So here we can say that logarithm is just a basic expression of an exponent. Logarithm is a basic expression for exponent, or just a form to express exponents. Yeah. So let's take again the general form. A to the power x is b. Now we can write it as log b to the base a is x, because here a is the base, b is the solution, and x is the exponent. Yes, that's an easier way to find the solution to an exponent, and that's how we generally express logarithms. And now here are certain conditions which applies with this whole expression or the logarithm form. Here, first of all, a can never be 1, and that why? Because if a will be 1, then 1 to the power x will always be 1, no matter whatever the value of x is, and hence a will be like becomes equal to b, and that isn't possible. And log isn't required for such things, so a is never equal to 1 and b is always greater than 0. And that is because if b will be 0, then there's no power of a that can make it 0. It is just undefined, because log 0 base a is undefined. Yes, so these are two logic behind these conditions. Why are these getting applied? Now let's proceed further. Now, there are some laws of logarithms which we must know. Yeah, and before that, let me just express it back. A to the power x b if and only if log b base a is x. This represents if and only if. Now let's start with the laws of logarithms. So let's look at the first law of logarithms, which states that log of a, b, two numbers a and b to the base c is always log a base c plus log b base c. Okay. Now to prove it, let's take on LHS. We have log ab base c. Now let's take c to the power something, say x is equal to a. Okay, so it becomes log a to the base c is x, right? So we can write a as log c log a base c. Okay, and from here we know that c to the power log a base c is certainly x, and c to the power x is just a. So that's how we take it into c log c to the power log b to the base c. Now we apply the same thing, that c to the power x is b, so log power c is b to the base c is x. So same like same reason, and whole to the base c. Now we know the one law of exponent, that a to the power b into a to the power c is a to the power b plus c. Now we use the same law of exponent, so log c to the power log a base c plus log b base c to the base c, and it is nothing but log a base c plus log b base c. Hence we proved the first law of logarithm. Now in the second law of logarithm is log, suppose a by b to the base c is always log a base c minus log b base c. Now the proof is very similar of the three primary laws of logarithms. So in this, we to prove it, uh, we take on LHS this thing, log of a by b to the base c as log c to the power log a to the power c by c log b to the power log b to the base c, and this whole to the base c. Now another law of exponent we have to use, that a power b by a power c is always a power b minus c. Yes. So it becomes log c power log a base c minus log b base c whole to the base c. So it's nothing but log a base c minus log b base c. So hence proved. Now in the third law of logarithm is that log, suppose b to the power d to the base c is always d into log b base c. Now for proving this, we take the same thing from the previous two laws proof. Yeah. So to prove it on LHS, we have log b to the power d base c. Now we can write b as c to the power log b base c whole raised to d to the base c. Alright, and so it becomes log c d log b to the base c whole to the base c, and it's nothing but d into log b to the base c. Hence we proved this law as well. Now these are three laws of logarithms which are required in all the logarithmic problems. They are very important and will be used everywhere. Where, like in the previous video, you might have seen that we use these three laws primarily in all the questions. So let me write it back here for the convenience. So the first law is log ab base b is a base c. Yeah, e base c is always log b base c plus log a base c. Second, log a by b base c is always log a base c minus log b base c. And third, log m to the power n base c is always n into log m to the power base c. Now for the next thing in logarithms, we have one important thing, and that is the base changing theorem. Now this is another important theorem which is used approximately everywhere in the questions of logs. So this theorem states that if we want different base, suppose there's an logarithmic equation, log b base a, but I want the base as not to be a but to be c. So for this thing, the base changing theorem states that log b base c divided by log a base c. So this whole thing is equals to this. Now how is it possible? So let's look at a proof for this as well. Now let log b base a be x. Okay. So this is if and only if a of x is b. Now log, let's take logs n base c. So log, on this equation we take base log of base c on both the sides. So log b base c is equals to log a to the power x base c. Now using the above law of logarithm, x into log a base c is equals to log b base c, right? So x is equals to log b base c by log a base c, and here therefore log b base a is equals to log b base c by log a base c. Hence we hence proved this theorem. Yes, so base changing theorem is very useful. Like if we have two different equations of different bases, we can make them both equal using this theorem only and itself. Okay, now we have one more thing which we can prove. So there's the property of logarithms that suppose a log b base a is always b. Now to prove it, let a log b base a be x. Now taking log on both the sides with the base a, so log a to the power log b base a to the whole to the base a is equals to log x to the base a. Now log a base is this thing is 1, so log b base a, and this we bring it in front of log a base a using the above law of logarithm. So log x base a is equals to log b base a. That means b is equals to x, and that means that a to the power log b base a is equals to b. Hence we prove this property. So Bayesian theorem and this property are other two properties of logarithms, which is derived from these three laws of logarithms. Okay. Now in the Bayesian theorem, there's one more thing. Suppose we have log b base a. Now if I want to make this in the base b, so what I have to do is log b base b by log a base b, it becomes this, yeah, and log b base b is nothing but 1. So log b base a is log a base b. Hence we can generalize through this that if there's a log with the base a, log b of base a, then to change the base of the log of the real log, we'll just take its reciprocal. Suppose we have log 3 base 2. Then to take the base as 3, we'll just write it as log 2 base 3. As simple as that. This is another thing which you all should keep in mind. Another property of logarithms. And other thing is, suppose we have log of b to the base a, and here a is equals to n to the power k. So if I want the base to be n, then we just need to express it in the form of this. And if we write it as this, log b to the base n to the power k, now we'll just take this power and bring it in the denominator. So log b base n by k. It just becomes this. And how is that? So here's the proof for this. Why have we written it as this? So let's take log b base a is equals to log b to the base n power k. Now using the base changing theorem property, I can write this as log n to the power k base b. Now I can bring this k here. Now 1 by k log n to the base b, and again using the base changing theorem back, log b base n by k, and we get the same result for this from this property. Hence, these are three other properties which we discussed right now. Yes, yeah. These are three other properties which should be kept in one's mind by solving the logarithmic problems. So that's how we do logarithms. Now, if we talk about the graphs of logarithms, so we have two graphs of logarithms, where one is a decreasing function and other one is an increasing function. Suppose we have log b base a, where a lies between 0 and 1. So for this, the graph will be like, wait, just a minute. Suppose this is our plane on which we need to draw the graph. Now, so for this, a graph will be decreasing function, right? Because it is decreasing as b increases. Yes. So a graph looks something like this. Wait. Now, if we have to draw a graph, there are two different types of graphs of logarithms which we need to keep in mind while if we get a graph question somewhere. Yes. So there are two types of graphs. So first one is log b base a, where a lies between 0 and 1. Yes. So this will be a decreasing graph or decreasing function. Suppose this is fx is log b base a, and here a this condition applies, then there is a decreasing function. Now how do we draw a graph for this? Now if it passes through 1, then it is a repeating function. Yes. So the graph looks something like this. It looks a bit ugly, but yeah, it looks like this. which is decreasing and decreasing continuously. And for the other graph is log b to the base a fx, where a is always greater than 1. Now this is an increasing function because as b increases, the value of log b base a always increases. Yes. So the graph looks something like this. Alright. So it's 1. Remember to always plot 1 because 1 is always a pairing function. We know that. Alright. Okay. So these are the two graphs. Now let's look at the properties of the graphs. So if we talk about the domain and the range, we can see the domain in these logarithmic graphs. Generally talking, y is equals to log b base a. So x is always greater than 0 in both the logarithmic graphs. Alright, and it is a domain, and y belongs to the real numbers, which is a range, because y is why each y is included in this graph. Yes, so that's why y belongs to real number is a range for these graphs. Now if we talk about the transformation, we need to understand the transformation first, which I'll try to bring it in another video. And so this is done for this video, in which we discussed the basic laws of logarithms, and we understood each law with their proofs, and some discovered some new properties. Yes, and discovered these two graphs, how we draw them on the plane. Now for further questions on graph of logarithms, I'll bring up a new video for that. And if you like this video, please share, likes, and subscribe this channel, and comment what you want in another video. Or if you have any doubts, you can always mail me on the mail ID in mail ID. Yeah. So thank you for watching the video. Come back for the next video. Thank you.